Okay, we're going to go ahead and graph radicals right now. And graphing radicals is no different than graphing an absolute value problem or a quadratic. It's just a matter of plugging in your values for x and see what it spits out for y. Now, there is something to think about when you're working with radicals. If you had just a very basic parent function of y equals x, you know that some perfect values to put in there for x would probably be the perfect squares, 0, 1, 2, or excuse me, 4, and 9. And they would probably spit out what you expect, 0, 1, 2, and 3, and so on. But with equations like this, you have to start thinking about what would create a perfect square or form a perfect square by plugging something in for x. For example, if we had a little t-chart here um, up top, and we were to think about what can I plug in for x here that would create one of the perfect squares, 0, 1, 4, and 9, because we know how to simplify those relatively quickly. So the question is, what plus 3 equals 0? Well, how about negative 3? Negative 3 plus 3 is 0. Square root of 0 is 0. What plus 3 will get us 1? How about negative 2? Plug in negative 2, you're going to have 1. Square root of 1 is 1. Now, what's going to create a perfect square for 4? Well, what plus 3 equals 4? That's going to be 1. Plug in a 1, and you're going to get square root of 4, which is 2. How about 9? What plus 3 equals 9? I'll plug in a 6. 6 plus 3 is 9. Square root of 9 is 3. Then we get to go ahead and graph these points. Negative 3, 0. Negative 2, 1. 1, 2. And plug in 6, and we get a 3. So we get this function right here. Now let's suppose we went ahead and graphed our parent function here. And let's use a different color here so it stands out. Let's use blue. I'd plug in 00114293, 0011, 42, and 93. And you'd see that we get the same type of graph. In essence, what happened is we had all these values from the parent function shift over 3 units to the left. Which would coincide with the function y equals a times the square root of x minus h plus k. Yes, our old friends h and k. So this is a horizontal shift. Remember, it's the opposite because it's h. 3 to the left is our horizontal shift, and we didn't have any vertical shift. It was just 0, so there's no vertical shift. Let's take a look at another one here. See if we can go ahead and get this graph. Okay, through the magic of modern technology, here's our next problem. And again, we're going to have to plug in some values for x and see what it spits out for y. Let's change this back to black. So now let's again think about the perfect squares, 0, 1, 4, and 9. So what can you plug in for x to make a 0? How about a 2? Fine. Let's see what happens. 2 minus 2 is 0. 0 minus negative 2, 0. So that one's done. What about a 1? What minus 2 equals 1? How about a 3? 3 minus 2 is 1. Square root of 1 is 1. 1 times negative 2, negative 2. Now we need to make a 4. What minus 2 equals 4? How about 6? And we're going to have the square root of 4, which is 2. 2 times negative 2, negative 4. I'll show you what that one looks like. Y equals negative 2 square root of, we said plug in 6 minus 2, and that's going to be negative 2 times radical 4, otherwise known as negative 2 times 2, and that's where we get y equals negative 4. Last one, let's see if we can make a 9. What minus 2 equals 9? How about plugging in an 11? And we're going to plug in 11. 11 minus 2 is 9. Square root of 9 is 3 times negative 2, negative 6. So now let's go ahead and graph this. Plug in 2, 0, 2, 0, negative 3, 2. I'm sorry, 3, negative 2, 6, negative 4, and 11, negative 6. So out here, all the way down to about negative 6. And our graph is going to look something like this. Something like that. But at least we've got the coordinates to help us out, and we've got a general shape from our graph. One thing again to keep in mind is that this really came from the parent function of the square root of x, which, as you recall, is 0, 0, 1, 1, 4, 2, and 9, 3. So not only was this graph flipped because of this negative, it was also stretched away from the x-axis by this 2 right here. And this was a horizontal shift to the right 2 units. Let's move on down here. Let's take a look at number 9 on your worksheet. And they asked you to go ahead and use a graphing calculator for this. So I'm going to pull up my handy dandy graphing calculator. And I'm going to plug in this into y1 and this into y2. See what we get. So let's clear this out. And I'll plug in the square root of 3x minus 5. So I'm going to hit second math, or excuse me, second radical, and plug in 3x minus 5. And then I'm going to hit my arrow key and plug in 1 minus x. Again, plug in the radical, 1 minus x. And we want to go ahead and see where both of these intersect to solve this. So I'm going to hit zoom, 6, and get a nice 10 by 10 by 10 graph here. Now, these do not intersect. So now the big question is, they don't intersect, so there'd probably be no solution. Let's go make sure we put these in correct. 3x minus 5, 1 minus x, good. And there's our graph. So you'd probably want to sketch this somehow, some way, somewhere. We'll move this down. Actually, I'm going to move this up here. Get our calculator back. And we could probably just do a quick sketch of this, if you would. Let's get a black marker here. Get the calculator back. And it would just be a rough sketch somewhere. It looks like it's right here. And it's going to go out like this. And then the other graph in reverse is going to go out this way. Now, the blue one, if you think about it, was the 3x function there, 3x, and then there was another one that was 1 minus x. So it was 3x plus, or 3x minus 5 was this blue graph, and the 1 minus x was this one right here. So if they were asking you to graph this, it'd see, is there no solution? Explain why. So for number 9, you would probably say no solution because both the graphs take off in opposite directions, or maybe a nice little sketch would be a better picture of why there is no solution. Let's take a look at one more here, or a couple more, excuse me. Actually, one more. Let's talk about a cube root. So as you recall, before we were working with perfect squares. Now we're going to be working with perfect cubes, like 0, 1, 8, and 27. However, if you look at this, 27 is not on our little graph. So I think if we stuck with 0, 1, 8, we'd have 3 coordinates and get a pretty good idea of the shape of the graph. So let's go ahead and create our handy dandy little t-chart here. And we're going to have our x and our y. So now we get to think, what plus 3 will get us a perfect cube? Well, let's go ahead and make a 0. What plus 3 is going to equal 0? That's right, -3. So we're going to plug in -3 and get the cube root of 0, which is 0, and we're going to be left with -1. So that one's done. Now let's create a 1. So what plus 3 is going to equal 1? Well, -2 does that. So -2 plus 3 is going to be 1. Cube root of 1 is 1. 1 minus 1 is 0. The next one is creating an 8. So I'm going to go ahead and create that 8. What plus 3 is going to equal 8? Well, 5 plus 3 is going to equal 8. The cube root of 8 is 2. 2 minus 1 is going to be 1. So let's go ahead and graph these three and see what happens. -3, -1, -2, 0, and then 5, 1. Is that all we're going to need for this cube root? I'm not sure. Let's take a look at the calculator. Let's change these. I'm very curious about these cube roots. So I'm going to loving modern technology. So let's plug in cube root, hit math, cube root, which is 4, and plug in x plus 3, and get out of that radical and type in -1, and see what that graph looks like. So it looks like as if there is more to this graph than just meets the eye. Let's start thinking about some other negative values we can plug into this graph to finish this off. So with that in mind, I would probably think about -1 and -8. Here's why. -1 times -1 times -1 equals -1. -2 times -2 times -2 equals -8. So we can plug in create some negative cube roots. So now let's do that. Let's try and think about creating -1 from our function. So what would I need to add to 3 to get -1? That's right, -4. Plug in -4, you're going to have -1. Cube root of -1 is -1. Minus 1, that's going to be -2. Now let's create a perfect cube for -8. How about -11 for 3? So if I plug in -11, and -11 plus 3 is going to be -8. Cube root of -8 is -2. -2 minus 1, -3. So let's plug these in. -4, -2, and I plug in -11, and I get 3. That would finish off the rest of this graph. That's going to make you dangerous for this worksheet, and I'll see you guys tomorrow.